Yes, Amy, it is being recorded. Can this let someone with Windows run Swift? Like Swift applications or just Swift dev? I guess so, because if you're on Windows, you would just run VMware, load Mac OS into it, and now you're basically on a Mac, even though you're running on Windows, a Windows platform. So yeah, that would work. By the way, Amy, I told A1 that I was recording both, and I'd let you know which was the better lecture, because usually B1 is going to be the better lecture, because I've discovered things in A1s, like all the oh shits come out over there. And in here, it's like it just goes really smoothly. It looks like I know what I'm talking about. So maybe B1 will be the one to watch. All right, here we go. So that's parallels for Mac. Business edition. Let's see if there's anything else interested in there. Yeah, you get all the good jokes too. B1 rocks. B1's my favorite so far. I shouldn't play favorites, right? We're going to do the same thing. We are going to run, basically we're going to run Linux, which is a Unix sort of operating system. You're going to run Linux inside of a container on your machines, and then that's where your debuggers, your compilers, all the tools you're going to use to actually build code will be on the Linux side. But we're going to use VS Code on a Mac or on Windows to work within that environment. It's easier to show you than to tell you about all of that, so I'll just show it to you. The nice thing about Docker is that they sort of took this idea of virtualizing an entire operating system and treating it as an application. They took the next step and said, well, why don't we do the same thing with applications? So maybe I want a database. Am I using MySQL or Mongo or Redis or something? Well, just create an image that has what you need. Like it's got Redis, if that's your database, and it's got all the stuff that Redis needs. Stick it into what they call a container, and now I can run that container on my box, and it's independent really from the rest of the stuff that's running on the machine. We're going to be running Linux, an operating system, and again, it's independent from everything else that's going on, but we can still connect to it and talk to it, and we're going to be doing compiles against it and so on. And by the way, the reason we're doing this, and it's a little bit of a pain, frankly, to get to the point where you're ready to dev, we're doing it so that we all have the same environment. It doesn't really matter now. Like you could just pop up VS Code and start writing code probably for the whole first half of the course, because it's really generic C code. But toward the second half of the course, now we're going to start looking at like operating system fundamentals and internals and data structures inside the OS and how we can connect C to those. And it's just so much easier if we're all using the same operating system. Otherwise, I've got to have exceptions for, the 9 different varieties that you guys are running. So that's why we're doing Docker, is to create a kind of a standard environment. And by the way, that's what industry is moving toward as well. It's just so much easier for them to create a Docker image that contains everything they want their company's devs to have, and then distribute that. And now they know everyone's got the same stuff. If you need to update it, you update it in one spot, and that filters down to all the containers that your devs have. So it's extremely popular right now. And I think it's like incredibly useful to learn too, because you're going to be using it on the job probably. Might as well learn it now, right? And in fact, in an interview, you can say, oh, yeah, I've used Docker, no problem. In fact, on your resume, proficient in Docker is how I would say it. Proficient in Docker and C. Let's go look at Docker. So what I'm going to do here is I'm just going to walk through an install, get it up and running, and then write some code. You're welcome to follow along. It actually takes a while to download stuff, so there's probably a little bit of time. But you're welcome to follow along, what I'm doing. But again, keep in mind that this is kind of Monday's activity, is to do the same thing, or at least get everyone up to the same spot. If you screw something up, I screw stuff up all the time. You just delete it and download it again and start again. Like, it's no big deal. So it's not, you can't really break anything doing this, so don't be afraid to like experiment and try things out and see what's happening. All right, let's go to Docker then. So here's Docker, docker.com. With the old get started button. And what we're interested here is Docker desktop. So the desktop is how we're going to manage Docker tools. Honestly, like you kind of even don't need the desktop because you can do everything from the command line. And honestly, I bounce back and forth between the desktop and the command line. I'm a command line guy just from way back. I mean, I started computing before there were GUIs. You know, all we had was a terminal. So that's what I grew up with. That's just how I work and how I think. Leanne says Windows and Mac. Yeah, so here's your Windows version. There's a Linux version. View engine for Linux, down for Mac, etc. So I'm going to grab the Mac version here. And by the way, because this takes so long, I've already downloaded Docker in A1, but that's how you get it. Just click the big blue download button and down it comes. When you start it up, when you start Docker up, it's going to ask for a couple of permissions the first time. It's going to want access to your network, which you should grant. The reason is that it uses the network on your machine to allow the running container to talk to your host operating system. So in this case, I'm on a Mac, the host is Mac OS, the container will be running Linux. They talk to each other on an internal network, and you need permissions to access that. The other thing it's going to want to do is get access to your file system. It's the same idea. We're going to take a folder on the Mac or in Windows, and we're going to map that into the container so you can see that folder on both sides. If I do something on the Mac side and just pop over into the container, I'll see that same information over there. It needs permissions to do that as well. So those are the two things it's going to ask for. I actually downloaded much more quickly than it did before. CB1's already rocking. All right, so let's start up Docker. Here is Docker. I don't have any containers running. I haven't downloaded any yet for you guys. So there's really only two tabs here, right? Containers and images. Oh, I actually did save that one. Oh, cool. I'll show you where that is. In fact, let me blow it away. I was going to remove that one. Sam asked if we need an account. I don't think so. This is one of those specific questions we might have to answer offline. It seemed in A1 that most folks were able to get to the image, and it didn't seem like they had to log in anywhere. There were a couple of folks who had issues. I'm not sure what those issues are because we didn't have time to look at them in lecture. My guess is that most of you will be able to grab this. And if not, like, don't panic, just follow along and we'll figure out why in a day or so. There's no huge rush on this, really. All right, so once you've installed Docker, and installing Docker, you just go to your downloads. There's a docker.dmg, which is the package file for Mac. It's going to be an MSI file on the Windows side. You just double click it, follow the steps, and it installs it. Yeah, George, that was a question in A1 too. Get a normal OS. I think there's a workaround. We'll take that offline on Piazza. The question was about M1 Macs, the new Apple Silicon Macs. There's some workaround that we need to do. And I don't have an M1, so I don't know what the workaround is yet. But we'll figure it out. All right, we need an image here. The images live in, actually this particular image lives on Docker Hub. I guess I could distribute it on, I wonder if I could stick it up on Piazza. I'll have to try that and see if I can put the image on Piazza for you guys, save you a step. But they live up here on Docker Hub, hub.docker.com. I don't think you guys need an account here. It's essentially Git. It's like GitHub for Docker containers. So if I look at my repos, here's one here. There's only one, in fact, called CS210. ParyDB UCS is my repo. CS210 is the container in this case. And I'm just going to download that container. I could just download it. Oh, 64 downloads, cool. That's all my guys from A1. Oh, I'm gonna do it from the command line because I prefer the command line. Once you've installed Docker, you're going to get Docker commands. Let me just hang on, export. I'm gonna change that prompt so it's a little easier to read. Where am I? That's the Mac, okay. Let's do an export PS1 is, let's give it a $sign. All I did was change the prompt there because there was this whole huge long prompt and it was just wasting space. So PS1 is the string that holds its prompt string number 1. It's the string that you see as a prompt on the command line, and you can change it to whatever you want. So I just said export, which makes it active. Export PS1, I'm going to set it equal to $sign space. That's why we see a $sign space over here. If I said something like, let's make it woohoo, woohoo. That's our new string. Looks like that. So you can do whatever you want. Clear. Nice. So you get Docker commands. I'm going to take Docker help here. And you can see there's a whole bunch of help information here, right? So by the way, oh, Bradley, what'd you find, man? Oh, sweet. Sweet. I'm going to grab that right now so I can bookmark it. Nice. Guitar. Let's put it in my reading list. Hey, Bradley, thanks, man. We'll get that. I'll credit you on Piazza. I almost said Reddit. I'll credit you on Piazza. So most commands on the command line, and again, like I'm a command line guy, you guys are going to end up doing a lot of command line stuff. In fact, part of the exercises we do in discussion sections are around the command line, exploring like, what are the Linux commands? Like, what do they do? Writing scripts, like maybe we'll write a script to change the extension on a whole bunch of files to something else or to organize them in some way. You'll be doing exercises like that kind of throughout the course just to get you used to using the command line and comfortable there. Because on the job, I'm here to tell you that you spend a lot of time on the command line in most development positions. It's just easier, it's faster. We all know them. It's kind of a language unto itself. So we'll get you up to speed to some level in that stuff too. It'll help you, certainly help you when you get your first real jobs. But on the command line, you often have help files, and there's 2 ways to get to them. So in this case, Docker help works. They actually have implemented a help command in Docker, and we get all this stuff. In some cases, like if I do like help ls or ls help, like no, that doesn't work. ls is a list. ls means list, and it gives me a list of files. And there's all sorts of switches. So if I want to see more information, I can use -l. Gives me a longer version of that. -l for long, I guess. For these commands, and mainly it's the built-in commands that are like this, we have to use the manual page for it, and you just say man, and then the command you're interested in. So man ls, for example, that's the command, all the switches and everything for the ls command. So one of 2 ways, either help, or rather command help, or man, the name of the command. You can get help that way. Yelp, whelp, yeah. I wonder if there's a command called whelp. Nope. Well, we should make one then, huh? All right, so we've got Docker installed. I'm going to do a Docker pull. Do I have it in my history? No, I don't. That's fine. I'm going to say Docker pull, and let's go look at the name of that container. The name was this guy. It's PeriDBUCS is the repo. CS210 is the actual container name we're interested in. PeriDBUCS. /CS210. And I want the latest version of this. So I'm going to put :latest. In Docker, you can build containers, and the container itself kind of becomes static. So let's say I had version 1 of my application and I built a container around it. That really wouldn't change. It would always be version 1. If I wanted version 1.1, I would build a new container, version 1.1, and stick a label on it. The label would be probably 1.1. The latest label usually points to the most recent. So that label, we actually add those manually. The way I manage containers is I always just make sure latest is the most recent version of something. It's actually the default. So if we just said pull PeriDB CS210, that would default to the latest. We'll put it up here just so you see it. So what it's doing is it's going up to Docker Hub, that repo, like GitHub, or Git or GitLab. It's pulling down this container, it's extracting it and configuring it for us. And once we do that, we should be able to run it. Extracting. Yeah, Malik, don't panic. We'll get you fixed up in the next day or so. All right, so there is our downloaded image. And now I'm just going to run it. I'm going to run it from the desktop because it's just easier. But there's a run command also, Docker run, basically. But we can do it from here as well. Oops, that's the web. Here's Docker down here. If I look at containers, images. So I've got this image. That's the one we just pulled down, right? I can just tell it, so I can run. Let's do run. Now, there are a couple of settings here. One of them you're interested in. I'm going to go create a folder. BU. This is 210. Let's stick it in 210. See these, like I get this test mapped folder. I'm going to create a new folder here. We'll call it test B1 because you guys are B1. And what I want to do is I want to share this folder between the Mac and the container. And that's done over here. It might be one that you actually already have. I just created one. Doesn't really matter. It's in the optional settings. You can name the container if you want to give it a nice name like Fluffy or something. Here's this volume, though. I want to map on the host. The host is the actual machine you're running on. I'm going to map this folder into the container this way. So here's that test B1 folder. There. And now I need to pick a place to put it in the container. The easiest place to put it, frankly, is /home. Let's stick it in /home. You're essentially creating a folder in /home. Slash is just the way we talk about directories in Linux and Unix. I'll show it to you in a sec. It's going to essentially do a two-way mapping. So from inside the container, I can write files there and see them on the Mac. I write stuff in the Mac, I'll see them in the container and so on. Let's run this puppy. Running. This name up here, by the way, is randomly generated. So you'll always see just a random name up here. Although somebody in A1 got Tesla honeymoon or something. It's like, oh, it sounded like Elon sending you a message. All right, we've got a running image now. In fact, there it is. That's the image that we started up. Now this is the container that's running. So the image itself, really all the images, it's just a description of what the container should have. And some binary stuff, like it's basically it's a disk volume, I think, essentially behind the scenes. But it's all the stuff you need to run that. So that's the actual container, the image. And then when you run that, you get a container out of it. So this image, I could start it up again and have a second container with the same stuff. So I'd have two containers running. They're kind of identically configured. And that's not so useful. It would be useful, let's say I had a container with the database in it, like MySQL or Redis or something. So I could have that container, run that, then run a second container that would use the Redis database container as its database. So the containers can talk to each other also. We'd use a tool called Docker Compose to set those things up. And we probably won't get to that in here. We do talk about it in 4.11 a little bit. This thing's running. So let's go and take a look. I'm just hovering here. So the very first hover is CLI. Now you can also stop this thing, restart it, just get rid of it altogether. If you screw something up, just delete it. No harm done. The file stuff, those mapped folders, don't go away because that's an existing folder on the Mac. It's not going to vanish when I delete the container. Just the mapping vanishes. Where did it all go? Here we go. So we want the CLI, command line interface. And it's going to launch a shell for us. Cancel that. That's the one I want. Let's get rid of that one. I'll make this nice and big for you so you can see it. How do we know we're in the Docker shell? Well, a couple of ways. In the tool that I use, which is the default on the Mac, you can see kind of up here, it says that's where we are. We're in the Docker CLI, Docker exec, blah, blah, blah. That's the command that was used to start that container up. We could also just do a uname, man uname. That's great. I didn't install man in the container. My term. Uname prints the operating system name. So we can run uname over here, uname-a, and you can see we're in Linux. It tells you what version of Linux you're running, which version of the kernel, what architecture it's been built against, and so on. This is a 64-bit Intel architecture. And let's do, where am I? PWD is print the working directory, so show me which directory I'm looking at. I'm up at the top. Let me go to home, CD to change a directory, /home is where we mapped that stuff. That was that optional parameter when we started the container. LS to list what's in there. There's nothing in there. Let's go put something there. Was it test v1? I want a new text file. Can I do something like that up here? New tab. Oh man, let's do it this way. I'm going to cheat. And it's going to go back to my, so this is the Mac side, right? Darwin is the Linux kernel. So, the Mac OS kernel, so we're on the Mac OS side. I'm going to change directory to that shared place. CD, test B1. There. And now it's going to create a file. Let's touch a file. Food text. We'll put something in it. XT and Control D to end it. So that is on the Mac side, right, in that shared folder. We can see it here. There's foo.txt. Now if we go over to the Linux side, there's foo.txt, cat foo.txt. Hey now. So you can see that file shared between the two systems. This particular container has the GNU compiler and debuggers in it. You can see the GCC is the compiler, -v will give us the version. So that's GCC version 8.3.1, which is fine. That's the current version. And the debugger is the same. GDB is the debugger, -v. We're, it doesn't actually give me the version of it, just that it is. Wonder why. Who knows? So GCC version 8.3, I'm assuming it's a similar version and not the debugger. You can if you want. So this question came up in A1. Sam asked, do we need to download iTerm too? That's just what I use. It's got a couple of fancy features, and I'm on the command line so much, even in Mac OS, that I want a terminal that has some features in it. It's up to you. There is a terminal on the Mac. It's just terminal. Actually, that's it. It looks just like this sort of blank whitey sort of thing. That's the terminal. By the way, there's Emacs here. Yeah, Emacs. XC. There's VI, in case you want to use VI. I'm not requiring anybody to use like Visual Studio Code. If you want to jump into the Docker container and use your favorite tool in there, that's fine. Really, the only thing I really need is that we're all in the same operating system. So if you're an Emacs person or you love VI or Vim, like you love that sort of working from the command line, doing builds, right from the command line, that's fine. It's slightly easier to do in VS Code. And depending on where you go to work, it's probably half a dozen of one or the other, which kind of environment you'll be in. So if you're like a more advanced user, maybe you already run Linux and you already have some dev tools, that's fine, just use your tools. At the end of the day, when you submit homework, you're really submitting it to Git, and we pull those files from Git. So if you've got some way to get your files into Git, GitLab is what we use, then we can see them, we can grade them. And we don't really even see what operating system or environment you were in, we just see the code. Frankly, that's the way I would work, because I think VS Code blows. It's not my favorite. The only reason we're using it is that it's got this nice old Docker integration feature that CLion doesn't yet, and they keep telling me that they're going to finish that up real soon now. And when they do, we're not this semester, but the moment they do, the very next semester, we're switching to CLion to get out of this Microsoft stuff. Sorry, was that too harsh? Sorry if you like Windows and shit, that's fine. I don't. All right, that's it. That's the Docker part. And some of you are following along, probably ran into some trouble. Like, there's always going to be trouble the first time you try something, right? It's kind of cheap for me, because when I come in and do demos a lot, it's like I remember, actually in 4.11, CS4.11, we talk about back-end, front-end architectures, and I do a quick demo. I build an application in Node on the back end, and then an Angular component on the front end, and show how to talk back and forth on a JSON API. So kind of in a decoupled sort of way. And I can do that in about 40 minutes. And it's just like, you do this, then you drag this, all this, and it's fine. What most students don't realize is I spent like a week practicing it over and over and over. I do it and then I blow it away. It's like, all right, do it again. Try it. What was that command? And I'd write it down and I'd do it again. So by the time I got to lecture, it's like, oh, it's so easy. You just do this and this and this. And meanwhile, so I'm sweating bullets back in the office trying to get it all to work. All right, here we go. Yeah, it does take a while. It's a big honking application. It's going to take a lot of memory too. I assume you're talking Docker. Yeah, see, it's really easy. Why didn't you know? Like 40 minutes, you all guys can do an application. Now let's go do it, right? But that's kind of how it is at work too. Like, no one's going to hold your hand at work. Well, maybe if you're lucky. Usually it's like, oh, we're using Docker. Go figure that out. And good luck. All right, let's put the Docker piece away. Next, let's look at VS Code. Do I have it downloaded, that one? Oh, I didn't. Sweet, I blew that one away too. Done. Let's go download VS Code. So VS Code takes us to Microsoft, the evil empire. Doodly-doo. Here we go. Code editing redefined. And again, this is just an editor. It's not a development environment, just an editor. In fact, it's just skins on top of Atom, I think. Nothing fancy at all. So it's going to be downloads here for various platforms. We're going to download it for the Mac. Off it goes. There's just a couple of things we need to configure here. There's one thing I forgot that needs to be configured, and so something broke in A1. We'll see if it works in here. If it doesn't, we came up quickly with a workaround. All right, cool. And because it's Microsoft, they don't put it in the right spot. So I got to move it from the downloads folder over to here, except I can't because the chat's there. Now I can move it over. Sweet. Yeah, I'll replace it. And let us. Now you guys run into trouble, don't panic. We'll hold some hands over the weekend and on Monday. So I just opened VS Code. Here it is. Make it a little smaller. And I'm going to blow this one away because I don't need that one. Don't need launch. There's our welcome. A couple of things you're going to need to do in here. And by the way, we'll post a tutorial with all these steps, so don't feel like you've got to like hurriedly write down everything I'm doing. There'll be a step-by-step tutorial for you to watch or read. I'm going to go up in this. This is the main menu, Code Preferences. There's Preferences. What I'm really interested in is, let's see, Code. What am I interested in? Code. Preferences, extensions. We need a couple of extensions over here, and I've already installed them. The first one is this C++ extension. So if you just type C here to search for extensions, the very first one that comes up is this IntelliSense extension. All that does is gives the editor some additional capabilities when you're writing C code. So code completion, syntax highlighting for you. If you didn't install this, you'd just see plain text when you wrote code, and the editor wouldn't help you in any way. You'd just be typing. Installing this tells Visual Studio's the code, it's like, oh, we're going to be writing in C. Install all these nice little fancy things for me so I can just hit a tab and complete a line and so on. So that's a nice thing to have. It's not nice, you really should have that if you're writing in C. There's tons of other ones that you'll see down here. This is the one from Microsoft. It's got a little star next to it. That's kind of the official supported version. The other one that we need is, we're going to work remotely. So I need remote container support. It's this one. Again, it's got the star on it. It's a Microsoft supported extension. So you basically just click here. It asks you a couple of questions, and you're good to go. What this gives you, that little remote container extension, gives you this, where it says Remote Explorer, this little icon over here. That will show us all the containers that we've got running on the system. So we'll go look, there's the container I've got, and I want to connect to it. So attach to container. Oh, I bet that was the thing we didn't do in A1. I just clicked over here. I really should have clicked attach to container. So watch what happens here. And I click that. It's relaunching basically. See, it says starting dev container down here. So starting it all up. And once it's done, we have this like second window here. Let's get rid of the original window. This specific container is now running against, this instance of VS Code is running against the container. They actually install a little bit of code inside the container so that they can talk back and forth. And we can see it. So if I create a new file, say file, new file, and it's going to say, this is my first C file. That's that's a comment, / // ends it. Now notice though that like, that doesn't look too cool, right? It's like, oh, it's just a bunch of text. It's because the editor doesn't know it's a C file yet. If we save this file immediately and give it a .c extension, now the editor knows it's a C file. It'll turn on all that fancy stuff for you that helps you out. And remember that we actually stuck this folder in /home. Remember we did that earlier? So I'm going to say I'm going to place this file in /home, /homer, that's for the Simpsons version. I could do it a couple of ways. I'm running in the container right now. So these are all Linux directories. If I say show local, it'll show me the same directory structure sitting on the Mac side. So if I just do show local here, let's say, yeah, it's in, test map folder. Let's put it in, yeah. And from there I want 210, test B1 it was, save. And I need to save this. I need to rename this, what I need. File, can I rename it somewhere? Save as, maybe? Save as. Test, we'll call it test1.c. So that .c, when I say test1.c, the .c triggers all those extensions for us that do the fancy highlighting and so on in Visual Studio Code. See, it turned green. It's like, oh, you're writing in C. I had no idea. Now I'm going to help you. It wouldn't help us before. Hey, Bradley, you're in luck. Somebody found, I think, a workaround. We'll post it on Piazza. I captured that for us. All right, first C file. Let's print hello world. Why not, right? So the print command, there are actually several print commands in C. The one we're going to use is a formatted print command. It's printf. And printf takes a couple of parameters. One of them is a string. Just going to type a string here. Hello world. Well, exclamation mark. Every line of code in C requires a semicolon. And you'll notice that if I don't have the semicolon, if I try to compile this, it would say, hey, you're missing a semicolon in line 3. So you'd have to go back and fix it. Semicolon. Let's run this. So if we were in Python, this would be print hello world, right? And just run. Dev says, why don't we put the main function in? I don't know, let's see what happens here. I'm gonna run it. Let's hit this little run debug button over here. It says run on it. See the guy over here? Does it run? Now, a couple of things are gonna happen. This is not Python or JavaScript or another language where it's interpreted. In interpreted languages, when we say run, it'll actually start at the first line or the entry point, usually main. It'll start at that entry point in the program, and Python, JavaScript, TypeScript, all those guys, they run it basically one line at a time. So that line is read, parsed, evaluated, executed, and then the next line of code happens. So all that's being done at runtime when you actually run the program. If there's any sort of error, like a syntax error or something, you're not going to find that until it's actually run. So you may have deployed that code to a browser, maybe if it's JavaScript. Once somebody actually runs it in a browser, the thing's going to crash because you had an error in your file. We didn't see that, though, until somebody actually ran it. In C and C++, and to some extent Java, here we're compiling these programs. So we do all that work up front. We take the code, check it for correctness. If everything is correct, then it creates an executable file for us. And it's that executable file that we can actually run. So we're doing all of our syntax checking, all our parse errors, like all that sort of level of checking is done ahead of time instead of at runtime. It's one reason why you don't see a lot of like enterprise, like big, honking enterprise applications written in interpreted languages like Python and so on. I mean, there's a Python compiler, I guess, but you want to make sure that the program is absolutely correct before you deploy it in a company. C, C++, Java, that's what is do that for you. If I'm deploying enterprise level stuff in JavaScript, I'm just asking for trouble. Olivia asked, what's a container? You can just think of a container as an application. In this case, the application happens to be an operating system. Could be another application as well. It could be a database or something. So really from our standpoint, it's just another app running on the machine. In this case, the container defines an environment. So it built Linux for us and added things like GDB and GCC and so on. So at the operating system level, we can make it exactly what we need. Like OSs are big, right? Operating systems are huge. my application may only need half of that. Maybe I don't need real-time device sharing because that's not what I'm doing in my app. So I just leave that stuff out. I can really trim down that container so it's just the minimum operating system I need, and then my application runs on top of that. And by the way, we're going to use containers for the rest of the semester, so you'll get plenty of chances to break things, to try things, to learn things. We learn stuff by breaking them, right? We learn from our error messages. So let's run this. Go and run. Run and debug. No, that's not what I want. Hang on. Escape, escape, escape. This is a stupid open folder /home. Let's open that one up. VS Code has this weird obsession with folders and stuff. I don't know why. I think of things as projects and structure within a project. It wants some folder thing of some sort. Connected to remote, open folder, home. Okay, I guess. I have no idea what just happened. Network volume? Yeah, sure, I don't care. Test one, let's run it. Run debug. Chrome, Edge, oh, come on. Why are you doing that? Let's try it this way. Run without debugging. Oh, great, now that doesn't work. Sweet. Do we have another instance running here somewhere? Do I want to install the recommended extensions for C? Yeah, I don't care. Fine. Installed, fine. Let's go back here. We're here. Can I run it from here? Build and debug active file. See if that works. No, don't show me that again. Where does it run? I did a right click here, and I'm going to do run and debug, build and debug active file. There we go. I think it was opening the folder made VS Code find the right build environment. I don't know why, sorry. So we're in GCC, go build it. Oh, there's errors. What are the errors? They're down here. Expected type specifiers, expected declaration specifiers. Holy crow, that's a lot of errors. Like, what do these even mean? Most of the time, when you get an error in C, you're gonna have no idea what they're talking about. I've been writing C since, oh, holy crow, the 70s. And I still have to look them all up because they're just so cryptic for some reason. I don't know why. Microsoft tried for a while in their Visual Studio stuff to make the error messages a little easier. They're just not. What you're seeing on the screen is not what the problem is. Somebody mentioned it up here. I can't remember who it was. This is not what a C program looks like. That's the problem. The problem is that C requires us to define what the entry point of the program is. Remember, we're building an executable file. We want to know where in that executable file to start. By default, and I can't think of a situation where you would ever change this, there's a function called main, and when the runtime sees a function called main, that's where it starts. So we need to define the function main here. So we'll just do it here. So we'll say int main void bip bip. And I'll copy this and stick it up here. And we're going to say return 0. That return, typically a C program returns a numeric value. 0 means success. 1 means failure. So if something has failed in your C program, it's going to return a 1. If everything succeeded, it's going to return a 0. And this function, so this is the function name, main up here. You'll notice this int in front of it. That int just says, hey, this function called main is going to return an integer. And there's our integer right there, that's 0. The void in here, inside the parentheses, is where we put the arguments that we're sending into the function. So if I've got any data, numbers, strings, whatever, I'm sending something into the function. They go inside the parens here. I'm not sending anything in, and so I have to tell C nothing is coming in, and the word for nothing is there is void. All right, this is looking better. Let's try this. Where was my little run build and debug? Sweet. I don't know why it keeps asking me this. Why can't it just know? Oh, it was so close, so close. All right, so what's the, the hell just happened? Let's see, where's our problem? So loaded, blah, 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 the output, there's no output, the debug console, exited with code 0. Should have had an error there. We can see it up here. Implicit declaration of function printf. What does that mean? So implicit declaration means you are defining a function called printf, but there's nothing else there. Like C doesn't know what you're talking about here. In C, because we do so much checking up ahead of time, you've got to give the compiler a lot of information about your code. For example, if I've got a function, I've got to have something somewhere that tells me what does the function take as inputs, and not the actual values, but what are the types? Does it take integers? Does it take a string? Like, what does it take? If it's returning some value, you have to define what's being returned in that extra information. So there's actually two parts of every C program. There's the code itself, and then there's that sort of compile level information about the shape of things. What values are coming in or what types are coming in and out of functions? What are variables? What kinds of variables do you have? What are their types and so on? And when I say type, I just mean, is it an int? Is it a float? Is it a string, an array? That sort of thing. Well, this printf actually is a built-in sort of function in C. Its information is in a standard file called, in this case, standard.io.h. That .h stands for a header file. So in C, you'll talk about source files and header files. The header file is what takes all of that kind of meta information, that information about the code, that goes in the header, and then the actual code, the implementation part, goes into the .c part, the .c file. Question was, does indentation matter? No, it doesn't. Thank you. It's 2021, like, what are we doing, you know, working in a language that uses white space as structural definition, like Python does? Like, who came up with that stupid idea? All right, we need to include information about the functions we're using, those header information files. So to include something, what do you think we'd use? What statement? Include, yeah. This is back, C was invented back when life was so much simpler. So we don't have to, like, you know, it's not include, you know, INCLUD to make it all hip and everything. No, it's actually the word include. We put a pound sign in front of it. These are actually, include is a directive to the compiler. Directives are just, we're telling the compiler, hey, go and grab this file. What include actually does, it literally goes and finds a file that you specify, it pulls it in and sticks it right here where the include statement is. So we're going to include standard.io.h. This bracket this way indicates that this is a standard file, and those live in a standard location. Standard.io.h. Studio. stdio.h. So include standard.io.h. Let's go find it actually on the system. Do I have a terminal here? So that's the Linux side. Let's go find standard.io.h. Can I see it this way? Which standard.io.h? I guess I should install which. How about where is? Where is standard.io.h? So standard.io.h, it lives in user include. Let's go open that up. Can I just click on it? That'd be sweet, huh? Open it. Oh, thank you. So here's the header file. It's big. See this all this over here? It's really freaking big. Let's go find, let's find printf. Here it is. So printf, here it is. It takes a character string. That char star means it's a string. A format, it contains other stuff. Like there's a couple of different ways to do it. But this, that line 332, the C compiler is going to read this header file. It's going to pull out this definition basically of printf and then use that to check to make sure we used printf correctly. Here's test one. All right, so let's see what happens here. What's it bitching about? No, it isn't. I just included it. Let's build it. See what happens. Build and debug. Son of a bitch. Did it work? Hello world. Hey, we got hello world. Sweet. I don't know why it's doing this, like, it almost looks like a double thing. I'll have to figure that out. Huh? But that's hello world. Let's take a look at this though. Actually, let's do it here. So where am I? Print work directory. List. So here are the files that that we created. So here's that foo.txt that we were playing with earlier. Test1.c is the source file that we're working on right now. And then test1 itself is the executable file. If we do I have files here? I have files. Do I have head? Yeah. It might tell us what it is. So head just prints out the first part of a file. Nah, it doesn't really tell you. I'll have to install file. I could actually do it from here. File. So if you do a file test1 from, I'm on the Mac side now. So it tells me what kind of file that is. The file command just tells you what kind of file. So you can see it's 64-bit executable on this platform. It's an x86 platform. Linking we'll talk about probably next week. Debug info, I've got it. And not stripped means that it hasn't stripped any of the symbols. Symbols are generated when we build this file. They're used in debugging. So if I want to stop on a line of code, it's that symbol file that's used to figure out where in the executable we have to stop, and then it maps it back into the source code that we provided. It takes up space. So if once I'm done and I'm satisfied that the code's fine, if I'm deploying this, I would strip the symbols to make the executable smaller. Actually, you can probably see some of them. Do I have strings? Test one. So what the strings command does is strings, this is still an executable file, right? This is a .exe if you're on Windows. I said, show me all the strings in that executable file. It just looks in the executable, picks out anything that it thinks might be a string and sticks it on the terminal for you. There's a hello world, that string in there. A whole bunch of symbols. These are all the linking information. I use strings sometimes if I'm trying to reverse engineer an executable file. Or maybe it's something that is a utility and I don't know what the commands are and there's no help for it anywhere. If you do strings against that executable file, sometimes it'll spit out all the commands that it knows because they're strings in the executable. Well, sweet, that works. One thing it did, though, is, let's run it again. Why it keeps doing that? Why are you doing that? The beauty is that by the end of the semester, I will also know how to use VS Code, along with all of you guys. So notice when this runs, I assume it's going to bip out on us again. See here? I got hello world, but then it immediately printed out the prompt, right? If I wanted hello world on its own line, like this is C, right? You have to do everything yourself. What time is it anyway? What do we go to quarter after? Sweet. It's C. You've got to do everything yourself. If you want to drop down to a new line, you got to tell C, hey, I want a new line here. The new line character is \n. We save that and do our little magic. Run and debug, build file and debug. Off it goes, and now we'll see hello world on its own line. Hello world on its own line. Let's create a variable in here. Instead of hello world, I want to put my name. In a formatted print statement, basically what you do is you've got the string that I want to print, and I'm going to embed in data that I'm going to display. And maybe I've got a char thing called name, and it's 6 long or so. So that creates a variable called name for me. In fact, let's set it equal to my name. 1, 2, 3, 4, 5. There's a \0 on the end of that, which is why I added 6. So I set up an array of type characters. This is a character array. Each element of this array will have a single character in it. The first will have a P, first 0 will have a P, 1 will have an E, 2 has an R, 3 has an R, etc. And I want to use that, I want to print it down here. So it's a little funky because again, we've got to tell C like exactly what we want to do. So I want hello instead of hello world. I want that variable, but this is a string, so I can't just drop the variable in here. It would just print out as a string. I've got to tell it, hey, this is a string. %S stands for string in that location. %I stands for an integer. %D stands for a decimal, essentially. %F stands for a float, and so on. So you tell in this formatted string what kind of thing you want to show, and then comma, the name of the thing you want to show. In this case, his name. Num. So I'm going to take the name variable, I'm going to print it out in the context of that string, here where it says %S. If I had 2 of them, care food, let's make it 6 again, why not? Woohoo. That's more than 6, by the way. Let's see what happens. So if I had 2 strings, I'd do it this way. Name, comma, food, like that. So that'll punch name, comma, food. That'll put 2 variables in for me. Let's do this one. Build and debug. Gotta be a way to map that to some button somewhere. Do you see that warning that just went by? So we get hello Perry. Woohoo! Oh, where'd that Perry come from? What's the string look like? Hello, string. So name is Perry, and then we print foo here. So we get hello Perry. There's woohoo. That's foo, right? Where'd that other Perry come from? Anyone know?
Doesn't it need to be so that at the end of each string there needs to be a 0, and if there's not a 0, then it keeps looking until it like finds a 0 in memory?
I think you're on the right path. Yeah, in other words, well, you're exactly right. So what happened was this. When we created these variables, we created 2 variables, right? Name and foo. When you create a variable, you're essentially setting aside in memory to hold that information and giving it a label. The first label is name, the second label is foo. I said that name is 6 characters long, or actually 6 slots long. So it's 6 bytes essentially. I've got 6 bytes in an array. I'm going to store Perry in that. So it's P-E-R-R-Y, is 5 characters. There's always a \0, this character. \0 terminates the string. you'll actually have to deal with that at some point. So if I'm copying strings around in memory, you have to take into account there's always going to be an extra character on the end, that \0, that terminates that string. Foo, again, I said, give me 6 bytes for foo. Well, how many characters are in foo? WOO, HOO, exclamation mark, right? What's happened here is that C has set up these 2 variables in memory next to each other. So it looks like woohoo is first in memory, and then Perry appears below that. There should be 6 bytes for each of them. However, I put 7 bytes or more in foo. So there's WOO, HOO, \0. I've got 7 characters in a 6-slot array. What's happened here is that 7th character, that exclamation mark, has overwritten the \0 that was part of Perry, because it's foo and then name in memory. So foo basically runs into Perry, and when we try to print it out, it doesn't know where the terminator is anymore because we overrode it. And so it just keeps printing characters until it finds a \0 happens to be on the end of that second variable, foo, or name rather, which was after foo. Well, it finally finds the \0 there, and that's why it's printing Perry, woohoo, Perry. It's because we overwrote the \0, which should have been there with that exclamation mark. We essentially put a string that was too large into an array. That will bite your ass over and over and over in C. That is the #1 source of errors in C, is not managing memory space properly. And it's I think it's one of the reasons like C is sort of perceived as being difficult, because we have to do so much manually, like within our code. I have to think about these memory allocations. Where is this being stored in memory? What's next to it? What size is it? What type is it? And so on. I've got to know all of that stuff. In other languages, like in JavaScript is the yellow lab of programming languages. It just does its best. In JavaScript, does the character 5 equal the number 5? What do you think, yes or no? In JavaScript, that's true. And the reason is JavaScript sees I've got 2 different types here. I've got an integer and I've got a character type. It guesses as to what I meant. It says, geez, I can't really compare a character to a number, but if I convert the character into a number, then I can do a comparison. That's what I'll do. And it doesn't even tell you it's doing it. It just does it and wags this little tail. It's like, oh, it's going to be so happy. This is called duck typing, by the way. And duck typing just means if it walks like a duck and quacks like a duck, it's probably a duck. So in JavaScript and other languages, duck typing takes over and it just makes shit up for you. It's like, oh, I think I know what you're talking about here. Arrays in JavaScript, you don't even have to tell it what size it is. You just keep jamming stuff in there. It just makes it bigger or smaller, whatever you need. It does all that for you. In C, no. C is like driving a manual transmission. You're constantly dicking with it. You've got to tell it exactly what you mean. It can become tedious at some point, especially early on, but then you kind of get used to doing it, and you do it so often that when an error pops up, it's like, oh yeah, I forgot to type that one. So you'll just get used to kind of thinking in that way. But C forces us to think about what's the underlying hardware that we're working on. What's the memory allocation look like? What's the structure? Which order are the bytes stored in? If I've got 2 bytes of information, 2 bytes of data, on some platforms, like on macOS or an Intel platform, for example, it's going to be the first part and then the second part stored in memory in that order. On a Sun Spark machine, it's the second part and then the first part. They're in a reverse order. You may have heard the terms endian, little endian and big endian, E-N-D-I-N, not I-N. It just means is the most significant bit on the big end or on the little end in storage. They're different depending on what you're actually running on. And so we need to know what platform am I on? How am I going to store this byte of information? It's that low level. As I said on Tuesday, it's almost like writing an assembler code where we have to have like intimate knowledge of the actual instructions on the CPU. This is one step above that, but not a big step. So there's a lot of stuff that we have to keep track of. You'll just get used to it. Like at first it'll be really annoying, especially if you're coming from a permissive language like Python. And then you'll like appreciate that power, that control, because you control every single aspect of the program.
Can I ask a question?
314. Guys, I think we did it. I think we actually, and I'm so happy that I figured out that one little button I should have pushed, because I'll tell everyone to watch the B1 version, because B1 is the better version, right? Of course. So you're going to see this again on Monday. We're going to release a programming assignment on Monday for you guys to work on. It'll be in this environment. So the first part will be just making sure everyone's up to speed in this environment. You guys on M1s, we'll figure that out. And that's it. So don't forget, shoot, one more thing. It's the Columbo method of teaching. You guys watch Columbo on reruns, you know what I'm talking about. The discussion sections. I appealed yesterday and won approval to run all of the discussion sections online. So all of the discussion sections are meeting on Zoom, not in person, not in person. It was hard to do. And I actually got yelled about it last week for trying it, and I got screamed at, and I went back and quoted Provost Morrison and said, this is why I'm doing it, and got permission to do it. So online discussion sections only. Yeah. You know what? The rest of the semester, yeah. The lectures are live. Please come to the lectures because it's nice to see your faces. All right, guys, that's it. Have a great weekend. No football this weekend, unfortunately.
Thank you.
Thank you.
You
Thank
too,
you.
guys. Nice to see y'all. Thanks for coming.
Thank you, Professor.
Sharing, I know. Stop recording.